Good morning, students. So today we are going to discuss about projectile motion. Projectile motion. Projectile motion. So projectile motion in the sense we have studied one-dimensional motion. One-dimensional motion means motion in a straight line. Straight line. Either this x-axis direction or horizontal direction or a vertical direction. Okay, or vertical direction. That is a one-dimensional motion. One-dimensional motion. So today we are going to discuss about projectile motion. What is the projectile motion? Projectile motion. Projectile motion in your school textbook it is given that motion under gravity. Motion under gravity. Okay. Projectile motion. Or projectile motion means the motion which are in two plane. Okay, a motion are in a plane. Sorry, not a two plane. Motion are in a plane. Plane means x-axis is there, x-axis is there, the x-axis is there, y-axis is there. Means in two directions. Okay, in a motion in a plane. So in this motion, suppose the particle makes an angle theta with the horizontal. Okay, so this kind of a motion is called projectile motion. Motion in a plane. So horizontal plane and horizontal axis and vertical axis. Motion in a plane, that is called projectile motion. Okay, so projectile motion. Suppose the particle is moving with velocity. Suppose velocity is u. Okay. So the particle makes an angle theta with the horizontal. So this velocity has two components. This velocity has a two component because it is a vector. So horizontal component is there and vertical component is there. So every point there are two components. Okay, vertical component and horizontal component. This is a vertical component, this is a horizontal component. Suppose u is the velocity of this particle, then it can be resolved into two components, u cos theta, that is in horizontal direction, and u sin theta is in vertical direction. U sin theta is in vertical direction. So horizontal component, so it is under the influence of acceleration due to gravity. Acceleration due to gravity is downward, so we take it as a negative. Okay, negative. So everywhere, suppose this is the maximum height at which the particle, maximum height, okay, the particle reaches the maximum height. So this horizontal velocity and this is a horizontal velocity and this is vertical. Every point there is a horizontal velocity and there is a vertical velocity. Horizontal velocity and vertical velocity. So this vertical velocity, we know that u sin theta, it decreases and reaches to 0 and then increases. Okay, so only vertical velocity. Horizontal velocity is u cos theta. So u cos theta is remains constant throughout the motion, and u sin theta decreases and reaches to becomes 0 and then increases. So there is a question that in a projectile motion, what will be the velocity of the particle at the maximum height? At the maximum height, velocity is not 0. Okay, if this velocity is 0 means this particle will fall to the ground. So this particle again moves in this way. That means vertical velocity decreases. Only vertical velocity tends to 0 and then increases and reaches the ground. And so this vertical velocity u sine theta decreases, decreases, decreases and reaches to 0 at maximum height, and then it increases. And u cos theta, horizontal velocity u cos theta remains constant throughout the motion. U cos theta remains constant. Okay, u cos theta remains constant throughout the motion. So that is why, since u sin theta at vertical at maximum height tends to 0, and due to this u cos theta, the particle again moves in this direction. And so in the question, u sin theta tends to 0 at becomes 0 at maximum height, and u cos theta remains constant. Now we have to find out, okay, so horizontal velocity is there, vertical velocity is there. So horizontal velocity is there, so there will be two acceleration, horizontal acceleration and vertical acceleration. Okay, vertical acceleration, we know that vertical acceleration is acceleration due to gravity, so it is minus d. Now horizontal velocity is constant, so horizontal acceleration horizontal acceleration is equal to 0, because horizontal velocity is a constant. We know that acceleration is a rate of change of velocity, so horizontal acceleration is equal to 0, and only vertical acceleration, that is acceleration due to gravity, because it is a free fall. Okay, acceleration due to gravity, so acceleration due to gravity is minus g. Okay, now we have to derive certain things from things. Okay, first we have to find out the time taken to complete the path, time taken to reach the maximum height and then fall to the ground, time taken, total time. So total time, first of all, we will its equation is t is equal to 2u sine theta divided by g. This is the equation. So first of all, we will try to by heart this equation. T is equal to u sine theta divided by g. Now how we will calculate time of a flight, 2u sine theta divided by g. Okay, so since we know that horizontal velocity remains constant. Okay, now suppose the particle moves from starting point and reaches the maximum height. Till the maximum height, what is the time taken to reach the maximum height? Again, same time it will take to reach the ground. So suppose we have to calculate the time taken from starting point to maximum height. Okay, starting point to maximum height. So at the starting point, the initial velocity is equal to, initial velocity is u sine theta, u sine theta. Okay, initial velocity is equal to 0. Initial velocity is u sine theta. Now at maximum height, maximum we are considering up to this point only. So maximum height velocity is equal to 0. U sine theta decreases and reaches to 0. Now we have to put the one-dimensional equation. V is equal to u plus at. Okay, so final velocity is 0. So 0 is equal to, now u is initial velocity. Initial velocity is u sine theta. U sine theta. Acceleration is a downward acceleration, that is minus. So acceleration is minus g into t. So u sine theta is equal to gt Okay, so t is equal to u sine theta divided by g. T is equal to u sine theta divided by g. So time taken for the particle to reach the maximum height, from starting point to reach the maximum height, is equal to u sine theta divided by g. Since again the particle starts from this point to reach the, so time on reaching the maximum height and the time taken to reach from maximum height to the ground will be same. So that is again t is equal to u sine. So total time taken for this particle to reach the ground, that is called time of flight. Okay, that is called time of flight. Time of flight, time of flight, total time. So total time of flight means twice of this one, twice of u sine theta divided by g. That means 2u sine theta divided by g. That is the total time taken for the particle to reach the ground. Okay.